So today's webinar session is really, again, part of our plan review series, looking specifically at energy plan review associated with fenestrations and doors. Now, a little bit of a heads up, we have been, I've got a very preliminary report back from our plan review coordinator to kind of quantify how much time do we spend on energy plan reviews as part of our projects across the jurisdictions that we work with. And a very quick, dirty first level look at it was, on average, we're doing a plan review of the 487 that she sent me in the last 2 years. On average, we're looking at about an hour to an hour and a half as an average. Now I'm going to do some more deep dive into that to kind of help us better understand what is energy plan review and how do we slide it into what we currently do to make it manageable. So don't be afraid. Don't think the plan review, just because we've broken into a six-part series, is really that much of is really a huge lift when it comes to energy code compliance. But we're trying to break it down into these smaller pieces to kind of reinforce the ideas that we've laid the groundwork for, so that when we go out and do them, we feel that level of confidence about what we're expecting to see, and also to be a tool that we can give to contractors and designers and say, hey, this is what we need from you when it comes to energy code compliance, right? What is the expectations and how do we get it done? And so some projects are more, some projects are less. But like I said, I'm still doing some data analysis so that we can give you a good idea. And once we get that ready, we'll just put it out there and let you guys have it, for those of you to kind of have a guidepost for where you want to get to over time, and how we do that as a team of plans examiners. So for those of you that don't know who we are and why I would even have that conversation, we're with the Minnesota Energy Code Support Program. We're a utility-funded education and resource tool for you throughout the state of Minnesota to help assist in meeting the requirements of the current energy code. We've been focusing a lot on the commercial, and we'll start to foray, moving towards some of that residential as the summertime comes. If there are opportunities, questions, topics that you want to bring up or have addressed, feel free to reach out to us, email us, or go ahead and put in to the survey when you leave those types of training requests, and we'd love to make sure that our trainings match what you want. But like I said, we thought this plan review series, now we're going to redo this plan review series again. We're going to modify the weeks a little bit, starting in June or July, one of those two. And so this will be maybe becomes a recycling conversation about plan review, because we know plan review is that thing that is a little bit intimidating more than others. And so if you do miss a series or a section, feel free to check out the website or just stay online. Eventually we'll get back around to it, right, the little round circle around to it. So let's just get started, right? So when my fundamental belief is that when we understand the why behind a question or behind a series of codes, it helps us to better to figure out the how we accomplish it, right? And so when we think about why we have an energy code, we've talked about this before, it's all about controlling the amount of energy we use in the design and construction of buildings to address concepts like heat loss, to address concepts like climate control, interior climate control. And it's also about, mitigating, controlling, influencing how much energy we use, right? Not necessarily what energy but how do we effectively and efficiently use energy, thinking about the usefulness life of a building. And so when we really think about that system, we see windows and fenestration and doors playing a significant role in that. And so we're going to go through this process, of defining what we think they are. When we think about design and the whole process of construction, we have the role of the designer is to one, begin with what is it they want to accomplish, and then how do we, there are certain things that are defined in the code. There are certain things that we have to explain on details. right? We can't stand over the back of our contractor and say, no, 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 I want this way. Oh, no, 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 we want this. No, no, you're doing this wrong, right? We can't micromanage construction practice. And so because of that, we have to make sure that we properly understand what it is we're trying to accomplish and then how we detail effectively on construction details what we're trying to get across. One of the things that we do as plans examiners and in the plan review process is evaluate that series of documents against the code to verify code compliance. And then, you once in a while throw in that little extra something of, does this even make sense? I don't know. So again, that's the role of plan review. And then after that plan review, then we get into the verification, the installation verification. And if I don't have a good plan, I can't build a good building, right? I won't build it the same way it was designed. It won't operate. It might work, but it won't operate the way we wanted it to, right? We want to refine and fine tune that building. Now, for those of you, I usually give us a few minutes. I try to now give us a few minutes to get everyone on. For those of you that are interested, the slides for today's class are online. So if you want to pull them up, put them on the screen next to you. Hopefully you've got 2 screens or 3 screens like I do. And you can follow along as we talk, maybe take some notes. If there's anything noteworthy. I think there's a lot. Anyhow, digression. But again, so we understand why we're doing, right? We understand now it becomes what we're trying to do is we're trying to control everything in our environment. And so as part of that process, we need to understand how we're going to do it and with what we're going to do it, right? And so that's when we start to really build on that conversation we had a couple weeks ago about fenestrations and entrances and those kinds of things, and really look at the whole system of doors and doors and docks and windows, right? Now we understand that the function, the purpose of fenestration is to be a component within our building's wall envelope, right? The building wall envelope is that series of materials that controls or protects occupied spaces from the environment, right? Here recently where I'm at, it's spring. It's spring in Ohio, which means it's time for tornado warnings and high winds and wet and rain, right? So last night at 2 a.m, we get the weep, weep, weep sound. I always love to be in a building conference when one of those alarms or alerts goes off, because it's like 600 people get the same alert, right? But anyhow, digression. We build buildings to keep us out of the exterior environment. And part of that is understanding we just can't live in concrete boxes though, right? Or brick boxes or vinyl sided boxes. We tried that, a couple thousand years ago when we lived in caves, and we decided we wanted to move out and then maybe put in these little things called windows and doors so that we could better control and have a comfortable interior environment. And so part of that understanding builds into what we see in the energy code as the building envelope and its purpose there in controlling and separating conditioned spaces within our building, right? So we have the building wall envelope, which protects us from the environment. And then we start to refine it even further. And in some instances, yes, it's the same wall. Sometimes it's not, right? But that's where we need to understand what it is we're doing inside that building and how those windows are going to affect that building. Now, when we talk about plan review before, like I said, we see plan review as, I always break it down to simple things. I'm a simple person. I like simple things. And so we break it down into those building thermal envelope, mechanical systems, heating systems, water heating systems, and power and lighting controls. And so we start to really get into this concept of they're all related, right? It's just how do we look at them individually that we've kind of broken it into these series of conversations. But that building thermal envelope builds on how we design a mechanical system, right? If I have as we'll talk about throughout this process, if my windows are not properly installed, I don't evaluate them properly in plan review, then the mechanical system is going to not effectively meet the demand it needs to. We may be oversizing, undersizing, overextending our mechanical systems simply because we put in the wrong windows, or because we didn't put them in properly. Same concept with lighting and power, right? We can conserve a lot of energy if we put in the right windows, so that we can have natural daylight. Or we can have dimming capabilities. I don't need the lights on 100% when I have some natural light, and let that, instead of it being a manual control only, right? We'll talk about that relationship between fenestration and the controls. Instead of, if I'm in a daylight zone, then I can have a lighting system or controls that may automatically dim so that I maintain a good amount of light at my workstation, but I don't have to walk over and move the little slider or just waste energy having it at 100% all day long. And we all know that we've got office. Some of us have offices that have those windows. Uh, I love a good office with a window. Now, trust me, I've been in the ones that didn't have windows, and you just lived in the little cubicle wall. And guess what? I like a 6 foot cubicle, not a 9 foot cubicle, right? Why? Because I get more natural light. Now, 4 foot, there's too much talking, right? 6 is about right, 5.5, 6, right? And that's the same concept. But again, how do we operate in that environment? Now, remember, when we're talking about building plan review, don't these are the expectations that the code identifies for the designer, and what kind of information should be provided. We are not asking for the world when we say I need to know what the U factor and solar heat gain are for the fenestrations, right? I've had some plans examiners and building officials said, well, I just feel bad asking for that information. We ask so much of them. No, that's because we want to build it right. That's our obligation. That's our duty, our responsibility, right? And the code says we're supposed to know certain information. We've talked about this all the time. I need to know what that fenestration is going to, how it's going to resist and control heat transfer, as well as heat transfer in and out through the assembly and solar radiation coming in through the solar heat gain. I need to know where those daylight zones are. This right here is the one that 9 times out of 10, I've got more problems with contractors on commercial projects with this design requirement. I need to know where the light is going to have an impact. So that if you're not, then just put a note in there that says none of the windows will create daylight. At least then I can mark it off and say, you've told me there's none, right? That 8-foot piece of glass is not going to do anything with natural sunlight. Okay, at least we know, right? And so we'll get into this a little bit when we talk about those fenestrations. Remember, when foundationally, the fenestrations are found in Chapter 5 of the Commercial Energy Code, right? We're going to see we'll see that they traverse, they go across multiple sections, but we generally think about them as part of the building envelope. And when we look at the mandatory requirements that we find in Chapter 5, it's number 2 of the 3, right? We have insulation, fenestration indoors, and air leakage control. Those are the 3 mandatory things to consider. And with inside that concept of air leakage, right, we have more expectations associated with how those buildings are supposed to operate, right? Because fenestration, at least from the mandatory line, right? If we look at the mandatory expectation for fenestration is that we follow the table. Really? Right? That we have some type of insulation installed and that we make sure that the building operates. It's not just a simple, well, it's got something, we're good enough. No, we need to make sure we calculate, understand those values. Fenestration, it's very similar. It says that, hey, you're going to have windows and doors in this system, right, in this building, assuming. And when you do, they have to meet the requirements of Section 5.8.2, which is the product installation and information section of the code. Remember, a lot of things that we see start in 5.4 in subsection 4, the mandatory, is then better refined in either the prescriptive, the alternatives, or even the installation. Those sections 0.5, 0.6, and 0.8. Right? It's just the way ASHRAE is. I know we've talked about it, right? It's just the way it is. So it starts off with, you got to do something. Here's how we layer on those expectations, right? It's like making a multi-tier cake. And so, when we think about how that all affects air leakage, the code comes back and says, hey, we have expectations for how those windows are going to leak, but then we also have other openings, right? Kind of going back to what we talked about before, like vestibules and loading docks, not locking doors, loading docks that are going to again impact the overall operation of this building. And so, how are we protecting, sealing, and evaluating those? So again, we'll look at some of that through the plan review process today. Now, when is a door a door? That's a great question, right? There's a dad joke there for you right there if you don't know, right? I'll look to see who puts it in the chat, the answer. When is a door not a door? Well, this is when a door is a door, right? And so we look at what those definitions are, right? And we have two different concepts that are identified. One is the building entrance. It's a unique definition or separate definition from a door or even an entrance door, right? This is where we start to get a little bit of confusion. But when we think about how they're defined, an entrance door is a set of doors or other methods of entering or portals for ordinarily accessing the building, right? That's a building entrance, right? We access and exit through an entrance. Now, we can have more than one entrance, right? But at least we know that what its purpose is the ordinary traditional access and ingress and egress from a building. Not a mean. Oh, I probably should use the egress word, right? Because egress means something. So entrance and exiting from a building, right? A door is different, right? A door is going to be that opening that where more than a half the door, or less than half of the door is glazing, right? So that's when we're talking about opaque doors. That's when we're talking about again, a door that has less than 50% glass or glazing is going to be a door. If it has more than 50% glazing, then it's a fenestration, right? It's a window. It's a window into the soul, right? And so there's going to be a variety of different expectations and way of defining and characterizing in the energy code the door. We have metal coils. We have non-metal coil, which is going to be, again, where we've got the upward acting non-swinging door assembly, right? The coil door. We've got the non-swinging door, which is going to be another roll-up metal coiling sliding door, right? That's not swinging. So it's anything that's not swinging. So it might be sliding. It might be overhead coil, right? We've got our sectional garage door. We know what that is, right? Goes up in pieces. We've got our swinging door, right? It's has hinges and pivots. So the code gets into this concept of what kind of door are we using. So it's not as easy as what is a door or not a door. But when we start thinking about it from the energy code perspective, what we're trying to do is determine how it's going to affect airflow and energy conservation. Building on that idea, we look at what is a fenestration, right? A fenestration is going to be any other opening in that wall system, right? And in what we see in section 5.4.2 and the mandatory requirements for doors is that doors and fenestration have to meet the requirements of 5.8.2, which tells us that we have to figure out the rating of any particular product. We have to label that product, that we calculate U factors based on a methodology and accreditation system, the FRC 100, that we calculate solar heat gain and visible transmittance based on the NFRC 200 series, right? That's what it tells us. And again, it's giving us this information to relay back how we determine what a door is, or what we expect to find from a fenestration. I was in a conversation yesterday with the building department at State talking about what it meant in the code when it talks about an approved source, right? And an approved source drives back at this question here. Who decides the U factor for a window? Who decides the utility rate for an energy cost budget analysis, right? Those are the approved sources. That's the process where we say, is it ASHRAE Book of Fundamentals, or is it, manufacturer's installation instructions? Was it done by the National Fenestration Rating Council? How do we know that this is the actual R value, right? How do we know that this piece of material, again, not to get into insulation, how do I know this piece of insulation is actually an R6 or an R1? How do I know the difference, right? I have to go back to the testing methodology and the certification, right? And evaluate, does this match with what we expect to see happen? And remember, there are all kinds of people out there trying to do all kinds of weird things and say, well, this window will work. No, I need to know. My job is not to say, yes, it might work. I need to have that level of clarity where I need to say, hey, I need more details. Remember, when my son just asked a little bit ago, can I go down to my friend's house? He knew before he even finished talking that he needed to give me more details, right? Can I go down to my friend Will's house so that I can ride bikes around the neighborhood? And then afterwards, we're going to go to Jackson's house and play football in the backyard till 2 o'clock, right? He knew every detail needed to be there for him to get a yes. And if he just said, can I go to my friend's house? The answer would be no. Similar to what we're talking about here. If I just say, hey, I'm putting a 3050 window door in. No, no, sorry. That's not enough. I need to know the U factor. I need to know, is it going to be glazed? Is it a fenestration or is it a door? Right? Is it an opaque door or fenestration? What's going on? And you just can't say I'm just putting a 24 by 36 window in. No, I need to have more than that. Right? And beyond that, what we'll see later, also, when we'll talk about it for the inspector side next week, we also need to have more detail on how to properly install it, because obviously, while we want to follow the manufacturer's installation instructions, some manufacturers are starting to get away from providing those instructions, right? Because there's too many lawyers in the world. Hopefully we don't have any lawyers on today. If we do, I didn't mean that personal, right? But anyhow, so what we're looking at is how does the code, how do we as building officials, as plans examiners, facilitate this conversation? So what are we looking for in that door? Right? We figured out what a door is. We figured out the method of testing fenestration versus doors. But what are we looking for? Well, we know based on our different areas within the state, our different climate zones, right, our counties, we may be looking at different tables to look at the insulating qualities of those fenestrations and doors, right? And that's all going to be based on an understanding of our compliance pass. Now, we'll get into compliance pass later on in more detail. But again, remember, not every compliance path is the same. And so in some compliance paths, we're looking at the door. We're looking at a table to say, yeah, this matches the table. Some compliance paths, like the energy cost of performance rating systems, Chapter 11 and Appendix G, we're really looking at, how does this operate as a holistic whole building, right? You may be able to go over or exceed a value in a door or fenestration based on some other thing. And we'll talk about some of that as we get into this. So again, opaque doors. We know that the expectation for those doors, when we talk about the insulating qualities, is going to be based on an understanding of, is this a conditioned or an unconditioned or a semi-heated space, right? There are going to be tables, right? We'll get into the tables on the next slide. But if we're in climate zone 6, we understand that there are certain times we can use a higher level or a less efficient window or door, opaque door, when it's that between 14 but no more than 25% of the total door area, right? So we get that exception for maybe one door, right? If I can get maybe one out of every 4 doors or something, right? It can be a little different. We see a lot of this when we think about, again, my favorite thing to talk about, convenience stores, right? You go to the back of the convenience store, and that door back there is the all opaque, tiny keyhole to look out door versus the front door where it's got full glass, right? And as we walk around the convenience store, we'll have multiple doors that have different glass levels, but one of those doors can be exempt because, again, it's giving us that exception. Doesn't have to be, but it can be. And that's one of those things where we might start to see a com check or res check taking advantage of that reality in our calculation process. But we'll talk more about com check later on. But again, climate zone 6, you're going to be allowed to go up to 1 door probably, or up to a certain amount of doors, up to that 0.36. And or 0.44, and in climate zone 7 we'll be able to go to 0.36. So again, those are exceptions allowed to the table for both conditioned and semi-heated, non-swinging, horizontally hinged sectional doors, right? So again, there's specific exceptions that we're looking for potentially there. But overall, when we think about the insulating qualities of a door, we're really looking at what we find in those tables 5, 5, 6, and 7, right? Where we're seeing that swinging door, whether it's non-residential, semi-heated, the swinging door at 0.37, which, as you remember, was 0.36 for the, yeah, 0.36 instead of 0.31 for that non-swinging door. And then again, if we got a non-swinging door, we're looking at, again, that 0.31 versus 0.7. So again, the basically we're looking for the same door expectations across the state. We just get that exception for one of those doors, or 14 to 25% of the doors when we in that exception rule. Thinking about, doors aren't the only thing to look for, right? When we think about the concept of fenestration. And so fenestration, again, we're looking at that vertical fenestration versus, and it's going to have to comply with the requirements in the tables, right? Now remember that includes everything that allows light to pass through, not to pass. And so what the code identifies in the definition of fenestration is going to be field fabricated, field built, site built fenestration versus skylights and vertical fenestration. Now, vertical fenestration is going to be anything that's not a skylight, right? It's kind of like what's commercial, anything that's not residential, right? So a fenestration is going to be anything that's not a skylight, but skylights are going to be anything that has a slope less than 60 degrees from the horizontal plane, right? So we may have some windows that qualify as skylights. It's not just, our mindset of what a skylight is, right? Depending on the slope, we could be looking at skylights. Now there are some maximum and minimum skylight fenestration areas, but guess what? Those minimum skylight fenestration areas are accepted in climate zone 6 through 8. So if we have an enclosed space, which is 90% of what we're talking about, the code doesn't give us a minimum requirement, right, on that. And so when we start to think about what does that table look like? What does those thermal values, those controlling elements look like in those tables? At the bottom of that table, let's go back a page. I'm going to jump back. At the bottom of this table, right, we have our normal wall. This is our normal table, right? We got one table, makes life easy. So we've got our roofs, our walls, our below ground slabs, our floors, and then we get to our opaque doors, right? Then we get to our fenestrations. So again, we're looking at that lower section of that table. In the lower part of that table, we start to see whether or not we have a fenestration from 0 to 40% of the wall. Now, what I want to remind you right here is when we think about, and we might reinforce this again later, the prescriptive process is designed for a wall that contains up to 40%. If we exceed 40% and we have an all glass building, we need to get away from prescriptive and go to a performance-based alternative, because this table is not designed, does not recognize a window that's greater than 40% of the wall, right? That's when we need to start looking at alternative compliance measures. That's why those alternatives exist. But again, we talk about fixed operable entrance doors. Remember, that was our entrance door that had more than 50% glass glazing. So again, what are the expectations for those values, those U factors and solar heat gains, and those visibility transmittance levels? How much light are we getting through that window, right? And then we have the skylights for 0 to 3% of the roof. So if I have a larger than 3% roof value, so let's say, let me use an example. Let's say I'm going to build a greenhouse tomorrow, right? And I want that roof system to allow in, not just the wall system, but the roof system is going to be qualified as a skylight. Then I'm not going to be using prescriptive. I'm going to have to go to a performance-based compliance path, right? Because again, it's only identifying 0 to 3%. That maximum of 3% of the roof system can be skylights. If it's more than 3%, kick it to the alternative compliance method, right? That's the expectation. That's the way this system, the prescriptive, is applied. Prescriptive doesn't work in every situation. That's why we have the alternative compliance paths. So that's what we see in group 6 and 7, right? For those of you that are in group 7 of the northern parts of the state. And what we're looking for is, again, we've talked about R values, we've talked about U factors in that context. It's the same concept, right? We're looking for a U factor is really looking at how much does this assembly of materials, right? The glass, the frame, everything that's in this assembly, not individual glass components, how much does it allow heat to transfer through, right? Through, either in or out, right? Depending on our season. We're allowing it in the summer and out in the winter. And how are we controlling that, right? That's that value that we always see, that U factor. The lower the number, the better it is at controlling airflow and heat transfer. Solar heat gain is on a 1 to 100% rating usually, because a 1 to 100%, 0 to 1, because what it's doing is it's giving us a simple calculation on the amount or percentage of solar radiation that goes through that material, right? So if we're looking at just plain normal clear glass, no special argon, no special multi-pane, single pane glass, that has a solar heat gain of 0.86. That means 86% of the heat coming through that from the sun's radiation is making it into my occupied space and affecting my occupied temperature. And so when I start to think about how does that affect my mechanical system, right? Well, if I've got a 86% of that solar radiation now beaming into my building, I'm going to have to heat this. I'm going to have to ventilate or cool potentially that area. And that's why we start to see the code starts to get into how do we restrict that? How do we regulate that? Well, we design it with different panels. We design it with different gases and films to reject that solar radiation. Still allows light through, but not the solar radiation that comes with it. Now, again, that's where we start getting that visible transmittance of light. It's not a code necessarily as far as a requirement that we get into too much, but what we're thinking about is we want to make sure you still get light through the window. It's not like, the car tent on the glass, right? Car tent, we want to keep the light out. In this scenario, we want to allow some of that light in. And so a 0.30 is going to allow for only 30% versus, again, 86%. 30% of that solar radiation can come in, and 70% is rejected by the window itself, right? So that's what we're looking at between the two systems. And that's why it's important that when we look at them, we're making sure we get the right information, that we're verifying apples and oranges and apples to apples, not apples to oranges, right? Again, if we were looking to the different requirements of Section 5.8, again, it goes back to this idea that manufacturers are going to be the ones providing this information, like we said, from NFRC 100 and 200 on how is this window going to provide, to perform, so that when I go to my project, I know what's in it. Now, we'll look at several projects today, in plan review concept to see. We typically get that nice window schedule. I call it nice, and I mean that somewhat facetiously, right? Because that window schedule does not always include that simple information on U factor solar heat gain. We usually get some comment that says, hey, we're going to be using this particular window system, right? And then and that's going to be the problem that we generally get into, is we need to make sure that we're referring to those two values together, right? And so we want to make sure that all the systems identified in this window schedule have a value, right? If we look at what they provided me, I'm getting a casement window. Well, guess what? That's one of the 17 windows I see. I need this value for every window. And if you know that they're going to have 3 types of window, fine, give me those 3 values. I need to know every window so that I know they're installed properly. Now, again, we'll talk about some examples here in a second where we can see the impact. But ultimately, again, we may get back into this is part of that conversation that may impact what compliance path we choose. right? Are we going to go with a com check? Are we going to go with a simulated performance? Are we going to go with a mathematical calculation on cost generation versus energy usage, right? Those are all things that we start to think about in that design. But let's say we get a com check. We know we'll talk about com checks more. Don't worry, this is not an in-depth conversation. What we're looking for is we want to verify certain information, and one of those things that we're looking for is that fenestration detail. And so one of the things when I do plan review, first thing I do is I always do a quick overview. Do I have a plan review and do I have a com check? Do I have an energy report somewhere in there? And over time, like we said, having done 400 of these over the last 2 years, in our team, we've now gotten to a place where most of our jurisdictions that we work with are giving this information quickly and at the first review, not as a second plan review. But again, we want to verify that if I have values here, it's not a quick and simple, oh, I see a green bar, I'm done, we're good. I'm going to take time to verify, do these values match with what the plan has? Because it's so often we see that the two start to become disconnected. As we make modifications on this piece, we're not always going back and say, oh yeah, let me rerun that plan check, that com check, right? That's where we come in as that final overseer and say, oh, no, wait, there's inconsistency between your com check and your values, right? And how they relate to one another. And so again, we're looking at more than just the table. We're looking at the totality of the event. And I just want to remind us again, if it's over 30% fenestration, 40%, sorry, 40% of that wall is fenestration, then it needs to follow one of those alternative compliance paths. And remember, we're talking about the width and height of the glass in relation to the overall wall. So while this is not 40%, this is probably 40%. And what I've been seeing a lot more of is actually where it gets a little bit interesting is where we start to replace some of these panes of fixed glass with solar panels, right? I've got a project where they were installing a significant amount of solar panels in these spaces because they didn't want all of that uncontrolled, because now you've got the opposite effect, right? You have uncontrolled light intrusion into spaces. And so if you wanted a dark area so that, or you wanted to have some more control or privacy, instead of having to install these wall to ceiling blinds and panel systems, now we can just install maybe solar panels in a wall system. Creates a little bit of different issue, but again, that would be wall versus fixed glass, right? Because that fenestration is for glass emitting light through it into the occupied or defined space. Now, like I said, it's not just a question of the fixture or the component itself, not fixture, the component itself. It's also a value or an evaluation of the impact of that fenestration on side lit and top lit zones. Now, we're not going to get into this. We've talked about this before, but one of the considerations that we need to think about when we're evaluating a building for energy compliance is, do we have clearly identified side lit, top lit zones, right? Now, this is going to be one of those things where the code provides us what the definition of what is a top lit zone or a primary versus secondary side lit zone and how we calculate that area. And one of the things that we want to make sure is that if there are 150 watts or more of lighting in this primary side lit zone, that we have photo controls over it, photo cell control. If light is adequate, if we're looking at this space, if this much light, we may not need these lights on full. I'm not saying we don't need them on. We may not need them on full, right? And so that occupant, that photo cell sensor will recognize the amount of air, not the amount of air, the amount of light, and then modify the artificial light to compensate. But that's in our primary is 150, and our secondary is going to be a total of 300, right? And what we're looking for there is independence in those controls. So that if I have a secondary lit zone, the lighting control isn't coming from the primary zone, right? Each zone has to have its own lighting control. And so again, looking very quickly, have we identified those zones? I'm not doing the math. Again, that's not my job as the plans examiner. My job is to look and say, is there a defined lighting zone? Yes or no? If there's not, then I need to have one because I need to be able to demonstrate that you are controlling the lights in that area to match. If you want to get away from this prescriptive requirement, what do you need to do? You need to go to a different alternative compliance path. One of those things to think about when we talk about those controls is their location and what they're doing, right? And so again, they can't be more than higher. They can't be higher than 11 feet above the floor, and they have to be able to continuously dim down to 20% or less and turn off those lights. Obviously, that's the whole point, right? So maybe this system of lights in this particular room, if that was in your office, and maybe this is probably maybe not something we're not going to see, at least at this elevation, right? This story in a Bemidji, but we might find it in a Minneapolis or a Duluth. And so again, if we've got these kinds of spaces, we need to make sure that we are able to dim them so that we're not using that extra energy and reducing those overall costs, right? We also have to have an unoccupied set point, which is something that we see if we were when we get into interior lighting, we'll talk more about this again, but this is just that real quick conversation. And again, there are going to be exceptions, right? And basically what it tells us is that if it's certain sizes or retail spaces or external projections, then we're not really going to have enough light to calculate, right? That's the whole point. If I've got a natural object, if I'm sitting beside a natural object that obstructs my ability to get light, then obviously I'm not going to have a daylighting zone. And so again, that's where I need that note that says there is no daylighting zone. Okay, at least I can say it's not me making that call. If you want to lie to me as a designer, lie to me, because then you're the one who lied to me. I'm not the one who didn't know how to read the plan, right? Or I'm not the one that ignored one of the mandatory requirements for the code. I'd rather, not to get into that conversation, digression. But again, what we're looking for is there a projection, right? And when we start talking about that projection factor, it's a calculation between height and distance and height, right? H horizontal versus vertical, or horizontal vertical, right? And so that relationship. So if we look at an example here, I've got a 5-foot overhang with a 13-foot wall. I divide 5 by 13, I get a 0.38. Remember, the code said if I'm looking at anything 1.0 on a north face or 1.5 on a south face, then I'm exempt from these side lit zones. Well, 0.38 is not 1 or 1.5, so you're not exempt. Now, if we did the opposite, right? Let's say, which I don't have in the graphic, if this was a 13-foot wide overhang and a 5-foot tall window, right? This might be something where, again, I see this more in like a high school setup, right? Or where you've got these large covered walkways beside glass windows. Well, then you're obviously not getting any natural light because you've got a 13-foot covered walkway next to a 5-foot tall window. So that's when you're going to say, okay, there is no natural light here. We're exempt from the side lit zone, right? But again, I need to know that. And we'll see some projects maybe that have that kind of calculation or variable. Same concept with skylights. Again, we're not required to have a minimum amount, but if we do have skylights, we need to identify what light exists in that top lit zone, what artificial light, and then identify, again, exact same expectations on controls. We'll look at this again a million times later on, but we don't have time to keep going. So again, we got a question, Q&A. Consideration for control timing on and off for control. Yes. So the question is there consideration for control lighting timing on and off for the controller? And that is going to be part of it. Yeah. So when you look at, you're going to have this unoccupied set time. So you may have it to turn off at, you can have time controls. And when we get to interior lighting controls, we'll get more into this. This is just one of the multiple options that we have on lighting controls. It just relates to fenestration, so I included it. But yeah, so you would be able to say, okay, if there's no lighting at 5 o'clock, then shut them off, right? You can time it out versus, if it changes and transitions. And what we'll see too is when you get into some of these, We don't want that like uh, that effect of the sunlight comes, the lights turn off, and then 2 minutes later a cloud hits it and the lights shut off. There's no reaction time, right? There's going to be some of that built into some of these technologies. So again, what I'm looking for in a plan is, did we identify a daylight zone? And if I got a contractor who's identifying daylight zone, he's also going to probably take the time to identify the wattage of the lights. So you can say, hey, this is the daylight zone, but we've only got 94 watts of power, so we don't need a control for it. Okay, I'm good with that. I can show that you've taken, I'm not going to go in here and double check and say, well, actually it's 97 watts. He's lied to me. No, we've identified the daylight zone. He's already identified as the design professional, the wattage of lamps supposed to go into that space. And now we know, do I need a daylight responsive receptacle or control in this space? And I don't, right? That's different than maybe this, where again, we have a daylight responsive control. We have a primary and a side lit zone, right? So this is going to be a vacancy sensor. We see right here, vacancy sensor versus an RPS1, which is going to be a photocell daylight sensor. And so this sensor controls this set of subgroup A's. This one controls subgroup C's. We see this area here apparently has a larger window. And so it's a further back primary side lit zone. So again, this tells me what I'm looking for when I'm looking for daylight zones on the plan. I also look a lot of times at the lighting control details, right? And one of those control sequences, do I have a time clock after 30 minutes prior, or do I have an automatic on with an override for a photo cell that targets a specific amount of illumination, right? Because again, this gets into where we get high-tech electrical design and electrical engineers involved to say, okay, I need this much light to make so my employees can work effectively. And if they're not getting it from the sunlight, then I need to get it from artificial light, right? So we can have that kind of a sensor conversation and look at those compliance paths and how we document it. And this is all going to build into what we see next week when we talk about how we inspect for it. If I know where to look and I know what I'm looking for, then I know what to verify when I'm in the field. But we'll talk about inspections later. I got too many slides to get through. So again, I'm looking for, again, some form of recognition that there are going to be skylights. And this is where they identified skylights to help fill some of these spaces. And my favorite convenience store, we've identified occupancy sensors. We've also identified photo cells, right? But what we see here is they identify on this plan, they identify the skylights, but they did not identify any of those photo cell controls. And so again, I asked the question, okay, where are the associated daylight controls for the top lit zones, right? What I need is a verification from somebody. I'm not doing the math to say how much light is in these areas, right? So again, that's part of that expectation. Again, my job is not to redesign. My job is to evaluate the design, and I'm not saying a control. And it could be something as simple as, well, that we don't have enough lighting or independent lighting control in that area. Okay, I need that comment from you because I'm not making that comment myself. Now, again, condensation rating is a component sometimes I see in different fenestration that comes in and comes out, but it's not a code requirement. It may appear on the label, and it's useful for some projects, depending on the weather, the humidity ratios. So again, just something to think about once in a while, especially for those that might be designers online. We have a few that join us once in a while. So let's look at a couple examples. Let's jump in straight into it. Now, this one is a little bit of a larger townhouse scenario, so it might not, so it's going to be based on stories. We're going to go with, this is going to be a 4-story building, right? We've got a first floor that's going to be more of a parking garage with some what do I want to call it? Storage space underneath, and we've got the 3-story, 2-story with a occupiable 3rd story. So we got 4 stories. We're going to make this project follow the commercial code. So we see right off the bat, we've got energy requirements identified, right? So we go to those energy requirements sheet. It's a beautiful looking sheet. I think we've talked about this sheet before maybe. And so when I go to this sheet, I immediately see a com check right off the bat. I'm excited. I'm thinking this is going to be positive. I've got all my energy requirements. I got my little zone map out. It's looking great, right? Look in. I see we have identified vertical fenestration view factors in one of the columns: 0.36, 0.43, 0.77 for these different types of fenestration. I'm excited. But I look over at my com check on the same page, and I see some inconsistency. I'm going to zoom in for us. I see windows coming in at 0.29. I see doors right above two rows above that, insulated swinging door coming in at a 0.4. Well, that doesn't look consistent with what I'm seeing here. So that to me is a conversation. That's a key note for me to start, right? There appears to be some inconsistency. So let's go to the door schedule, the window schedule. We're looking at windows. So I go to the window page. Beautiful window page, right? Gives me the schedule at the top, right? Gives me schedule, gives me some example, gives me some flashing directives and details. Woo, be still my heart, right? So I start to look at the schedule, and I notice I've got two items, right? I got a 0.27 and 0.28, but my com check was a 0.29. My column value was a 0.36. I'm getting some definite inconsistency vibes, and I've only got two of the seven, right? No, two of the six windows identified as having a U factor. So again, there appears to be some inconsistency between the U factor values specified in the com check and the tabular values, the values in column B, right, under vertical under fenestration. And we need to provide all of the values associated with the windows in the window schedule on page whatever this was, right? So this comment is going to say, hey, I need these numbers, because if I'm going to properly evaluate and my inspector is going to do his job, we need to know what's actually going to be installed. Now, sometimes if the whole world was all well and all these values were 0.27, 0.28, and I looked and it was supposed to be a 0.29, I'd leave it alone, right? I see some solar heat gain of 0.22. This one's 0.24, right? I start to question, where are these windows? What am I getting, right? If we are proposing or specking out something better, I generally leave it alone. I'm going to probably get yelled at for that, get some bad fan mail. But if it's worse, right? If I know it's a value that's greater than the com check or the performance report, then I'm going to ask that it be corrected. I need to go faster. See, I spent too much time at the beginning. We should have started here, right? Maybe I'll do that next time. So again, we'll go back to that door, that entrance door, 0.77, right? We go over here. This is giving us a value of 0.260 for that entrance door, non-entrance door. Anyhow, where was our entrance door? Exit door. 0.40 for our exit door, right? So I go to my table, same kind of a table for my door schedule. I've got a nice door, got door framing details and values. I look at my list. I'm looking for a 0.26 door. I zoom in, right? I've got a series of interior and exterior doors. Scroll over, and I see now I feel confident, right? I see that 0.26, which was reflected in my com check. And I see that at least we've taken the time to knock out those interior doors. I don't need to know the U factor for the interior door, right? Well, at least in this design. And so again, what I have that separate, I can now finalize this. This doesn't have the issues that I saw in the other one, right? I've got the values. I can move forward. Another example, let's look at this project here using the Appendix G calculation, right? This is looking at a energy cost calculation. So this is an addition to this is anyhow. And what we're going to be, so we're looking at, again, the proposed design would have cost, the baseline would have been $400,000, right? A total energy cost of $557,000. The proposed design is $500,000. They're saving 10%, $50,000. Somebody's going to be happy, and if it doesn't work right, they're not going to be happy. right? But we see in the envelope in that proposed design, I'm looking for windows that have a 0.40 U factor and 0.29 solar heat gain. So I go to the Windows section, right? I see that, from my perspective, I'm looking at this as an Appendix G compliance. I see they've met or exceeded the requirements, so they've passed. Mark 1. Now I need to verify that what we're expecting, what made them pass, is what I find. So I would evaluate all these elements. We're not going to do that. We're all looking at fenestration. 0.4, 0.29. I go to that section of windows, and guess what I see? Nothing, right? This is all I get in the legend associated with the windows. It identifies all the windows as V1 and V2s, S1s, but they don't give me any values that says C specs. So I go to the spec sheet. And when I go to the spec sheet, I see U factors valued at 0.4 BTU per square foot times the height times the degree of temperature. Well, that doesn't make any sense. And then I look at the entrance doors, and I see 0.63 times. And so what they've done is they've not completed the spec book. So guess what? This isn't helpful at all, right? When it comes to certain components in that design, my entrance door, my fixed glazing. Now, what I do find ultimately is I'll find a low E glass that's prescribed, talks about its daytime, nighttime values versus summer daytime values at 0.29 maximum, which matches with my solar heat gain, or exceeds my U factor calculation, and the 0.25 exceeds my requirements for my solar heat gain. But again, there's inconsistency. You told me in the report that we were going to get a 0.4, and now you're telling me I'm getting a 0.29. And I also have this confusion back here of what even is this, right? So again, I need that clarification from my designer, what's going on. Now we know, I don't have a whole lot of time, but we know that also one of the considerations in that process, not just windows and doors, but we also have loading docks. We know they need to be sealed. And so we see that detail come out in our design, right? We got to follow the chain, right? Go back to a spec book, which I hate spec books. But we go to the chain, we find out the spec book is going to have this type of weather seal on my exterior door. So I know it's been spec'd. I know now that when I go out, that it's going to be identified, how it's going to be identified in the field. Same concept with door switches, right? Depending on the type of door we're looking at or the type of wall system we're looking at, again, section 6.510 in the mechanical section gets into if we have conditioned spaces, we need to have a disabling door switch so that if this door is left open for extended periods of time, that we're not heating the outside, right? We saw one of these working perfectly fine up in Detroit Lakes earlier last year at the end of the year, right? Had an overhead door, it was open, and guess what was not on? The heating unit. Perfect, right? That's what we want to see. We want to identify those. And again, we understand that when we have entrances that have those automatic closing doors, it's not required, it's exempted. But areas that don't have a thermostat, you can't control what you don't have, right? And certain types of alterations to existing buildings. But again, if it's going to be open for more than 5 minutes, right? If it's nice out, we want to make all these windows open at a nice little restaurant or something. Then again, we're going to shut off the air conditioner or the heating units. And so when we look at that on a plan and we see sliding folding glass doors, glazed doors and walls, then if it's more than 40 square feet, I need to see some kind of control. We'll talk more about controls. We talk about mechanical design, but I just want to bring it up real quick as that relationship of how fenestration is in everything. It's part of how we evaluate air leakage. Again, there's tables on tabular values on how we calculate that air leakage of individual assemblies. So again, they should come that way. I'll do this last one and then I'll be done. So this is a hotel. It's about 260,000 square foot hotel with 130,000 square feet of residential units over here on the side. I look in, I see this nice, beautiful energy simulated, total building simulated design, right? We're looking at a performance alternative. And so I can start to evaluate this project. I go straight to that report. Again, they're telling me that we're going to save close to 20%, $200,000 by following this method, right? And the one person I don't want to be responsible for failure is Josh Harmon, right? I want to make sure that this gets in there. And so I look at my envelope. My windows right here are going to be a low E glass at 0.29 and 0.39. I look over in this report. This designer tells me that that window, those opaque doors and windows, should be found on pages A201 through 209, right? The sheet location. I'm getting excited by it, right? I'm a little bit concerned because you're telling me we got our 0.29, we got our 0.29, but I go to pages A201 to 209, and guess what? There's nothing about the windows, right? There's not even a reference point. It just tells me that each of these windows exists. And so, again, now I got to go to the spec book. I want you to, if you can see it, it says right there, which you probably can't, 1,302 pages of spec books, right? So, and there were 3 volumes of spec books on this project, close to 1,000 pages of construction documents, 3,000 pages worth of spec books. And so I finally go to my weather, my glass. I go down, I see that there's no uncontrolled leakage. Beautiful. I see air leakage controls that match my standard. Great. I see an overall value of 0.38 and 0.45. Well, wait a minute, that doesn't sound right, because the plan said it was 0.29 and 0.39, not 0.28 and right? I'm looking for a fixed window of 0.34, right? Or a fixed window of 0.29. I'm getting a 0.38. So I've got some consideration here, because what you're speccing and what you've designed to operate are not going to be the same. And so again, that $200,000 of savings is not going to be realized if we put in the wrong windows. So again, that's how we review for fenestration. I know I kind of talked way more than probably normal, but well, probably not more than normal, but as much as normal. So if anybody has any questions, obviously you can throw them in the chat, or if you can always, I'll stick around for a little bit. Next week, we're going to talk about inspecting fenestration indoors and how to work those relationships. And then we're going to get into comm check. And then mechanical design after that. So some of you guys are going to be more excited than others. If you do have questions or different training topics, please use the survey. I read those and pay attention to them. You probably should get a series of, I think we've got 2 weeks of CEUs to send out today and last week. And then if you have any questions, feel free to send me an email. Use the code helpline if you have any questions throughout the process, or reach out to us by email. You guys have a great week. Be safe, and I will see you soon in person somewhere along this road. So you guys have fun.